Grasslands are reservoirs for a huge amount of terrestrial carbon. These ecosystems also face challenges such as drought and wildfires. In 2018, the Great Plains experienced one of its worst droughts, and in 2020, Australia's Black Summer wildfires experienced horrible consequences and burned millions of acres. It's important to understand how these ecosystems store carbon in order to help facilitate their recovery. One way to do this is by looking at their associated microbes, which mediates nutrient cycling. A way to look at microbial communities is by looking at where they are the most active. And in this case, it's the rhizosphere, which is a very thin zone immediately around plant roots that allows them to talk to microbes by releasing sugars and organic acids in order to select those that can protect them and help them grow. However, plants are not the only things that can shape this underground world. Protists, which are microbes with a nucleus, eat smaller microbes such as bacteria and archaea. While there are a lot of well-known studies focusing on individual microbial domains, we don't fully understand the complexity of their interactions over a period of time. How do prokaryotic communities react to the presence of protists? How do they react when protists are not around? Does this change nutrient availability inside of the soil, and how do plants respond to this? To answer these questions, I conducted a 12-week greenhouse experiment where I grew grass that is very common in grassland ecosystems and different microbial inoculations. Some soils were highly complex. It consisted of prokaryotes, protists, and fungi. Some soils were less complex and consisted of only prokaryotes. And some soils had no microbial manipulation at all. I then analyzed nutrient availability and microbial communities by measuring gases that were released from soils over a period of time, and I'm using DNA sequencing in order to understand an association between plant and microbial interactions. My current results show that the presence of protists does in fact affect the nutrient availability inside of soil. I'm now using DNA in order to find out how these tiny, unseen microbes can influence entire ecosystems. This knowledge can help us build healthier soils, build plant resilience, and even mitigate the effects of environmental disasters. Thank you.